Assalamu alaikum, everyone. Good afternoon. Welcome to the Sharjah Academy for Astronomy, Space Sciences and Technology for another bi-weekly lecture. So as some of you may know, so every 2 Wednesdays, we have these special lectures given by our research assistants and also by some of our special guests. And today, we have the privilege to have Ms. Maryam Al-Qasimi. She is part of the High Energy Astrophysics Lab at the Academy. And she will be talking today about the history of women in physics. This is very important because, as you know, today, so women are a very, very important part in our daily lives. If I talk about the Sharjah Academy for Astronomy, Space and Technology, more than 50% of our staff is female, so this is great. So they are participating with us in the expansion of the academy and also in what you do as research. So the title is very important for all of us, and Maryam will take time, inshallah, to 30 minutes, 40 minutes to present her topic. So please, Maryam, go ahead.
Thank you, Hassan. Yes, so hello everyone. Thank you for joining us today for our presentation. So I'll have a talk titled A Brief History of Women in Physics. I really like the Arabic translation of it, so I'll mention it as well. تاريخ الموجز للمرأة في الفيزياء. So my talk will be consisting in the following way. We'll have first the history timeline of different physicists within different history eras, and then some of the science explained of these women. So we'll first go into ancient history and the women in physics at the time, then the Middle Ages, then the 19th and 20th century, and finally the 21st century. Then I'll be explaining three women, the science they've done. First, I'll take Maryam Labia, then Andrea Migliore, and Maryam Zahid. So in ancient history is the time between 3000 BC till 500 AD. They say that the end of ancient history comes with the end of, or the fall of the Western Roman Empire in 476 AD. So the first one we have in around 19,000 BC is what we call Aganis or Atherta. She was an Egyptian princess working in astronomy and natural philosophy. She lived in the Middle Kingdom. The internal policies of Middle Kingdom really encouraged the advancement of art and science. So we had a lot of scientists and physicists at the time, notably Atherta. In the 150 BC, we have Aglaé Wanki. She was the first female astronomer to be recorded in ancient Greece. What's interesting about this one is they used to say that she was able to make the moon disappear, but historians translated that into that she was able to predict the time and space and the place of a lunar eclipse. Finally, we have Hypatia, where she's a famous Greek mathematician because she was a great scholar. She was a good teacher and had her own science academy. She was an astronomer and a philosopher and was head of her own science academy. This is a description of her. So we move on to the Middle Ages. This is from the 15th to the 5th to the 15th century. And we know that the golden Islamic age was from 8th to 14th century. So we have a lot of Muslim scientists in that age. Most notably, in the 10th century, one was called Maryam Zahid. She was an astronomer from Aleppo, invented and developed the complex astrolabe. I'll be talking more about the astrolabe and what she did in her life later on. And then we have from the 10th to the 11th century, Fatima al-Majridi, or from Fatima di Madrid. She was an astronomer and a mathematician from Andalusia. And finally, we have Lubna Al-Qurtubiya, an astronomer and mathematician with extensive literary knowledge. She was even the calligrapher of Andalusia. She was really a power on helped to develop a library there that hosted more than 500,000 books. Next, we move on to the 19th and 20th century. We have Edith Ann Stoney. She was born in 1869 till 1938. She was the first woman medical physicist. What's interesting about her is like she grew up in a scientific family. Her father, mother, and aunts were all scientists, which helped her to become the first woman medical physicist. Sorry. Okay. So next we have most famously Marie Sklodowsky-Curie. She was the first woman to win the Nobel Prize and the only person to win the Nobel Prize in two different categories, physics and chemistry. So she won the Physics Nobel Prize for her pioneering work along with her husband in radioactivity and advancing the field of radioactivity, while her chemistry Nobel Prize was for the discovery of polonium and radium. She is a French-Polish physicist, Polish by birth and French by marriage. So you could see that that's from her name. She was, even though that like she lived and studied in France, she was really proud of her Polish origins and taught her daughters Polish and talked with them with Polish. An interesting fact about the Curie family is it's the most who won like the family that won most Nobel Prize of a collective of 5 Nobel Prizes. So she and her husband have 2, her daughters have 1, her son-in-law has 1, so in total is 5 Nobel Prizes. In 1943 was born Jocelyn Bell Burnell. She was an astrophysicist who, as a postgraduate student, discovered the first radio pulsars. What's interesting about her is like she did that as a postgraduate student, so it's an inspiring thing that people could accomplish stuff even though they're still like in their studies. Yeah. So next we move on to and died in 2017. She was the first woman to win the Fields Medal. Technically, she's not a physicist. However, she's a mathematician. However, her work really affects the theoretical physicists and engineers, so that's why I included her here. I'll be talking more about her even in the next slides. Next, we have, oops. Next, we have Fabiola Giannetti. She's the first female CERN Director General. CERN is the General European Organization, Research Organization for Nuclear Physics, Nuclear Research. So it's placed on the borders of France and Swiss. It hosts the biggest particle physics experiments there. And she is the first female CERN director. She was like 2021 was elected for a second term. Okay, and then we have in 1965 was born Andrea Migliore. She's an astrophysicist who discovered a supermassive compact object, black hole, in the Milky Way's galactic center, which won her the 2022 Nobel Prize in Physics. So these are what I thought they were interesting. Their work and life was interesting, but I'll choose 3 out of this to explain more about the physics they did. So first is Maryam Labia. She is also known as Al-Jalila bint al-Jalil. She was a daughter of an astronomer, which helped her to learn from a young age to the skies and to understand the astrolabes. She was born, she's from Aleppo, northern of Syria, and she was a maker of astrolabes. So what is an astrolabe? It's an instrument that you can see here. And I don't know if you can see my cursor. Yeah, here. This is it. We have a front and the back it's a device. It has a front and a back. It has different elements in it. This is we call the womb, the mater and lymph. This is the plate that is the spherical universe is celestial sphere can be put in the plate. Here this is important to note because I'll be explaining how you can determine time with using that. What we have is star pointers. This shows us the placement of stars in the sky, and the elliptic ring, which is the position of the sun throughout the year. Okay, so this instrument is really has many functions. It can predict the prayer time, rising and falling of the tides. They usually call it the Swiss Army knife of ancient celestial bodies, because of its many functions. Okay, so how can we use this? So as I said, this shows us the celestial sphere in a plate here. So we can determine any position of any celestial body in the sky using this. And this is the positions, it's the elliptic ring, which shows us the positions of the sun throughout the year. And these are the star pointers that are like, you can see them in the sky. This we call al-addad, and which you can determine the angle of the celestial body in the sky. By determining the angle, you can determine different stuff in the sky, the time, the position of that object, and so on. So here, if we can see that knowing the position of a celestial body in the sky gives us the time of the day, and so on. So it will be different at different times, and it will be different because of the different locations of the sun throughout the year. The time would be different, depends on the angle, and so on. So I will be showing you how you can use an astrolabe. It does have many functions, but I'll show only how to use it to determine the time of the day. So as I said, the sun throughout the year we can see it from our perspective in Earth to have different star constellations behind it. So in January 1st, the position of the sun will be at that position, while in March 1st will be different throughout the year. And this is the night sky. The night sky, we know of its famous constellations and famous celestial bodies. For example, this is a red Betelgeuse star that's important for us to note. So if we know the position of this star and the position of the sun in its elliptic ring, we can determine the time of the day. So how do we do that? First, we know that it has a back and front. So in the back, we can know the date is October 3rd, for example. If we look here, and place this on the October 3rd, we'll know the position of the sun in the elliptic ring. So by that, we can fix the sun in the elliptic ring in the different positions according to the date. And then let us assume that we know where or how we can determine Betelgeuse in the sky. So we will place it here. This is Betelgeuse. Then we look into the celestial object in the sky, which is Betelgeuse, and try to find the angle of that object to finally go back to the front of the astrolabe and align the angle that we computed here with the sun to give us the time of the day. So again, if we need to know the date of the day. So if it's October 3rd, we find October 3rd locations in the elliptic ring from the back and place it here. And then we define a known celestial body as Betelgeuse and look for that celestial body in the sky and find the angle to finally detect the time of the day. So Maryam Zahid was famously known to develop the complex astrolabe and to work on that. Second, we have Andrea Migliore. She was an American physicist who won the 2020 Nobel Prize in Physics, becoming the fourth woman to win the Physics Nobel Prize. So she won that prize for her discovery of a supermassive compact object at the center of our galaxy. She did this through looking into our center of the galaxy and studying the stars in the center and trying to predict its orbit and how it's moving. So she did that through infrared, imaging the galactic center at infrared wavelength and to peer through the dust and blocks of visible light to reveal the images of the center of the Milky Way. So the telescopes she used are very high in spatial resolution and made it possible to follow the orbit of the star around the black hole. Okay, so to understand, okay, she was able to follow up the path of the stars around the black hole, but around the center of the galaxy. But how did she, how can we say that because of that there is a black hole at the center of the galaxy? To understand that, I will need to first understand what is space-time. We need to first understand what is space-time. So what is space-time? So historically, we know that space position was three-dimensional and time was like one-dimensional coordinate system. So, and they were separate. However, space-time, as it's indicated in Einstein's theory of relativity, these two are connected to make up what we call space-time. It makes up a curvature of sort that covers our universe. So the space-time curvature is affected by the mass. So the heavier the celestial object is, the deeper it goes into that curvature. As you can see here, the sun being a less heavier mass than the neutron star, it doesn't go in as much as the neutron star and the black hole. So this is what we can define as the space-time curvature. So knowing that, So knowing that tells us, can tell us that if there is a heavy object at the center and something rotating in it, I mean, if we have something rotating around an object, that means there is a heavy object at the center. Because in general, let's assume we have a black hole at the center and we have stars around it. So as star moves around, they do move around the influence of the gravity because of the space-time curvature of the universe. The gravity of whatever inside the orbit. And we can determine how the mass of that object if we know how fast is the star are moving and the size of the orbit. So by knowing how fast are the stars moving around an orbit and the size of that orbit, we can determine the mass of the orbits inside. So Andrea used that facts to study the center of our galaxy and to try to prove that there is a black hole inside at the center of our galaxy. How did she exactly done that? She used the W.M. Keck Observatory's twin telescope in Hawaii. These are one of the, it is the largest telescopes in the world. She used it to take an image of the center of the galaxy in the infrared spectrum. We know that our EM spectrum goes from gamma rays to X-rays to ultraviolet to the really small visible light band that we can see with our own eyes. Then infrared and microwave and radio. Infrared, we can't see it with our own eyes, so we use the telescopes to image that. So she used the twin telescopes to take infrared images of the center of the galaxy. This was never intended, the design of the telescope for that, but she persisted to propose this project and to work on it. to take the images of the center of the galaxy and to remove then restack these images on top of each other to remove the effects of the atmospheric turbulence. What's really interesting about her work is like she first started with the optical waves. Let me try to start this, and where you can see the movement of these stars over many, many, many years. So here's, she was really interested in SO2 star that was able to complete a full orbit within 16 years. But that was not really clear. Then adaptive optics were really famous. So she used adaptive optics to be able to really distinguish the positions of the stars and the shape of the stars. So you could see the difference between the adaptive optics when they're off and when they're on, which is really nice. And finally, here is the final work that took almost 25 years. You could see these stars all rotating around or orbiting around a center, which is this, the star shape is actually the black hole at the center of our galaxy. And she was really interested in the star SO2, which is this one, the yellow one, because it was able to complete a whole orbit in around 16 years, which is really exciting because it's something in our lifespan where like, we can witness. Because of that work, over the span of 25 years, she was awarded the Nobel Prize in Physics in 2022. Half of it with Roger Penrose for the theoretical part of it. Okay. So finally, we have Maryam Mirzakhani. She was, as I said, not a physicist actually, but a mathematician. She was an Iranian mathematician, the first woman to win the Fields Medal in math. It's like it's a really prestigious award. It's the equivalent of Nobel Prize, but in math. It's even more prestigious since it's awarded every 4 years, not every year, like the Nobel Prize. So she won that for her outstanding contributions to the dynamics of and geometry of Riemann surfaces and their modular spaces. I'm not even gonna attempt to try this, to explain this because it's a bit really mathematical heavy. But in general, what does that mean? She was able to combine what we call geometry, which is the shapes and the positions of stuff, with dynamics, which is the forces and the motions due to these forces together, not in something that we can understand, but something with curved surfaces. For example, she was able to, for example, geometry in our world, what is it? It's the locations of our solar system. Yeah, the location and positions of the solar system, the size of them. And this is the geometry, while the dynamics is how these objects are moving. So she was able to link these two things together mathematically, but not in something that we can see, but really abstractly in a mathematical surface, curved surfaces, and so on. So she was awarded the Fields Medal for her work, and which have many effects and applications in theoretical physics and engineering. What's interesting about her is that she was her birthday was fixed to be the International Women's Day in Math Day, and what's another interesting fact is that we share the same birthday. So my birthday is the same as the International Women in Maths Day, which is really nice. And yeah, that's it for today. Thank you all for your attention. Any questions?
Thank you very much, Maryam, for this nice lecture. So please, if you have any questions. Please.
Excuse me, Miss Maryam, may I ask a question or just a comment,
Sure.
please? Thank you.
Yeah, go ahead.
Thank you for the nice talk. What do you think, from your perspective, Do you guess? Do you expect that someday there will be an Arabian woman among these names, the well-known names?
Yes, I hope so. I mean, as history showed, that there were Arab women that pioneered in physics, especially in the Middle Ages, which is that included the Islamic Golden Ages. So why not? Yeah.
And in order to do that, what do we need?
I think we do have the tools right now, right here,
Yes.
to aim for like international things. But we do have the tools. I mean, it's possible. It's just like work hard, I guess.
You know something that one of the Lebanese astronomers, she was a young woman, and she worked also on the supermassive black hole, the identification of the stellar orbits around this supermassive black hole at the center of the galaxy. And she was a member of that team. That was 10 years ago or something like that. But her name is not mentioned there. Yeah. Okay. So we hope that one day we'll see one of you as a well-known figure in the field of astronomy and space sciences. Thank you very much.
Thank you.
Any other question, please, from the student?
Doctor?
Please go ahead.
Actually, I tried opening the registration link, and are we required to use our university email, because it's not allowing me to use that?
Well, you must use it because this is the way I know that you attended. If you write your private email, it will be very hard for me to know who you are, and I won't be able to look into all the class list. So
Yeah,
please,
because it's telling me that the email format is it's not matched. I should match the email format. I don't know why.
Okay, so you can write your name and parentheses. You can write your ID and use your private email in such a case.
Okay, thank you.
You are welcome. Any other question, please, for Miss Maryam?
Assalamu alaikum, Dr. Elias.
Walaikum
This is
salam,
Muhammad.
Yes,
Muhammad,
yes.
Allah yabarak fi.
Fadal.
Just, this is not a question, but an invitation to our colleagues, all our colleagues, especially women, for come out up on the exhibit and start to touch and learn about the Astrolab. You know, we have a very good Astrolab up in the exhibit, and she gives, Maryam, she gives a very good example about how to use the Astrolab. And this is an invitation to come up and to know us, and we can explain for them and learn from them also if they have another, because Maryam, she used the date, she used the hours to find the date of the month. And also we can use the angle by positioning, for example, the sun, locate the sun, and find also the hour in the day, the time. And this is an invitation, please come up, and it's a very good Astrolab. It's the same as Maryam Astrolabia. That's all.
Yeah. Thank you very much, Muhammad. For those people who do not know us very well, so at the Sharjah Academy for Astronomy, Space and Technology, so we have a team of scientific guides. So Muhammad Hani is one of them, and they run the planetarium plus more than 80 space exhibitions. And as Muhammad said, there is a special corner where they have the Astrolab, and they can come and they can use it and they can train on it. Yes, so please, you are welcome to come. Following the new schedule. So we are open Monday through Thursday from 8 a.m. to about, I believe, 3 p.m. Yes, thank you very much, Muhammad, for informing us.
Okay.
Yes.
Thank you, Maryam, Dr. Elias. Okay.
Thank you. Any other questions, please? Any comment, if you wish?
Yes, Assalamu alaikum and everyone.
Yes, please go ahead.
Thank you, Maryam, for the presentation.
You are far away, Marwan.
I'm very far. I would like just to add one scientist. She's alive now. I would like everyone to read about her. She's called Shadia Habbal. Shadi Habbal is a professor of space weather in US, and she is very well-known name in astrophysics and the space weather. She got many prizes, but not, of course, those big ones like Nobel, but she is one of those who really deserve to read about them. Shadia Habbal, thank you.
Yes, thank you, Marwan. I believe just to come to finish this presentation. So there are hundreds of women scientists all over the world, being Muslims or non-Muslims. So there are hundreds of them all around the world, and they're contributing a lot to our knowledge of science and everything else. So thank you very much, Maryam, for this presentation. And I hope that all the students, all those who attended today's presentation, so they have learned something new. So thank you again. This is the first presentation of January 2022. So we have a lot. So we do advertise these activities every week. And so please keep up with what we present, and hopefully you will learn a lot about how we do science, how we observe, how we practice our everyday work here at the Sharjah Academy. So again, thank you very much, and see you next time, inshallah.